This is a wonderful night. We're here to recognize Professor Hank Levy, who we'll introduce in a bit, as the first holder of the Wissner Slivka Chair in Computer Science and Engineering. This is an event of such significance that Ben has left behind his customary Hawaiian shirt and short pants. And there are many people here to recognize, and we'll do it through the course of the evening, but I do want to thank right away Regent Bill Gates Sr. for joining us tonight on what is his 79th birthday. So thank you so much for being here. And happy birthday. I promised that we wouldn't sing, though. Just over a year ago, most of you joined us here to dedicate this building. It was a building that was made possible through the University of Washington and the state of Washington and hundreds of friends and alumni, including many of you. And at the time, we said that this is a program that's about the people, and the reason we built this building was because of what it would make it possible for people to do. And tonight, we're here to focus on that people part. We're going to join together in honoring Hank and Ben and Lisa and the wonderful recognition for Hank and support for computer science and engineering and its students and faculty that they've made possible through the Wissner Slivka Foundation and the creation of the Wissner Slivka Endowed Chair in Computer Science and Engineering. So let me begin by just saying congratulations, Hank. So to help us kick this off, I'd like to introduce University of Washington's new president, Mark Emmert. Mark.
How long do you suppose it's going to be before he stops introducing me as the new president? Probably about the first time I do something he doesn't like, be my guess. Well, I knew this was a special event, of course, because of Hank and this wonderful chair that we're celebrating, but when I saw Ben in a tie and Bill on his birthday, I knew we had a very special event here. This is a delight for me because I, like Ed and everyone in the university, understands full well the point that Ed was making, and that is that universities are not mostly about people, they are entirely about people. When you talk about universities, people often conjure up images of elegant buildings like this one and beautiful grounds and lovely campuses and the physical presence of the place. But of course, those buildings, those grounds, that place has only one purpose, and that is to attract and support wonderful people and wonderful minds to do the kinds of things that go on in great universities. And so to have Ben and Lisa support not only this wonderful building, but also this chair is, I think, a remarkable gift. And we are so pleased and delighted that you've decided to support this college and this university in the many ways that you've done, and we can't begin to thank you enough. I was so grateful, in fact, that to make a couple of Northwesterners feel comfortable, Northwestern University graduates, that is, I converted the Husky football team to a Northwestern football team, just to make it work well. So that when Ben and his son and Lisa came to games as my guests, they got to watch a team in purple lose badly. And Ben said, "This looks so familiar. Thank you ever so much. But you need to know my generosity only extends to one season. So we're going to try hard to do that." But to have, folks locate here and come back to their home and to become such active members of this university and become adopted Huskies is, well, in one case, a real Husky, of course, is a real pleasure for us, and we couldn't be more pleased. And, of course, to have Hank be recognized through this great award of the first Wissner Slivka Chair is absolutely perfect. So on behalf of the entire university community, let me extend first my congratulations to you, Hank, and our deep thanks and appreciation to Ben and Lisa. Thank you ever so much for all that you do for us. And with that, I would like to introduce Ben.
Good evening. Well, Lisa and I flipped a coin, and it ended up with, I guess I was up, so I get to speak. It's been a while since I've spoken in front of a big audience, so I'll check my notes quickly. So Lisa and I were here a year ago for the dedication and of this building, and Bill Gates and Paul Allen spoke very movingly about their time at the University of Washington on the grounds, exploring various buildings, looking for computer time, and I'll leave it at that. And I wasn't as clever as they were, so I actually went to the University of Washington's Academic Computing Center. That building is still standing, but it no longer has, I don't think, a mainframe in it. And I opened an account, and I paid real money. In fact, in 1977 I spent a little over $3,000 on computer time. And you got charged for CPU cycles and printing cards and printing paper and doing little plots on the plotter and everything. So, and I brought an artifact from that time. And some people may recognize what this is. And it's I'll just read the blue part down here. It says Computer Center, University of Washington, CDC job card. So this is actually a program that I wrote. I was paid for by the Musicians Union to do some actuarial projections. And my dad was in the symphony at that time, and so that's how they knew to find me. Anyway, so I had some connection with the University of Washington as a student at Garfield. And in fact, I found out about the school I eventually went to because there were two programs that were copyright Northwestern University. One was SPSS. They had ported that statistics package. And the other one was a program called NU Chess, which was a chess-playing program, which soundly defeated me. So that's a little bit about that. Lisa and I became involved in the computer science and engineering department about 3 years ago. And when we got, an innocuous piece of email from Ed, yeah, that's who it was, and I'm trying to remember who it was that gave him our email address. Maybe it was Brad Silverberg. Yeah, I think that's who it was too. So anyway, but through that process, we got to learn about the computer science and engineering department and the great work that's being done here. We're very impressed by the faculty and by the students and the diverse set of projects and research things. So that's been very thrilling for us. And so when we had the opportunity to endow this chair, that was a great opportunity for us. And so we did. And then when we learned that Hank Levy was going to get the chair, that was great, not only because of all the wonderful computer science work he's done, but here's a guy who's even more of a building nerd than I am. He spent a tremendous amount of time on this building, and I spent some time on a few other buildings, and so I really appreciate that interest he has in building things, not only with software and computers, but also architectural things. So thank you all for coming. Thank you.
I'd like to now introduce Denice Denton, because Denice has been here 9 years now, I guess, and has done nothing I didn't like. I'm going to introduce her as the new Dean of Engineering.
Well, it's a real pleasure to be here this evening, and first and foremost, I really want to thank Ben and Lisa for their commitment to the Department of Computer Science and Engineering and for this extraordinary gift, which will have a transformational impact on education and research. And I think we should just take another moment to thank Ben and Lisa for their real contribution. I want to also congratulate the Department of Computer Science and Engineering. In this college, we have 10 academic departments, we have 200 faculty, and I'm really proud of the success of this department. CSE has a history of strong leadership going back to its founding in the late 70s. It's created a truly outstanding group of faculty, students, and staff, And it's really created an environment that honors innovation and collaboration. And I believe, as many of us do, that the department is a crown jewel of UW, the region, and the nation. And it has a huge impact on everything related to the high-tech economy in our country. Central to my responsibilities as dean is the realization that success and excellence begins and ends with people. In the College of Engineering, people are really first and foremost above all else that we do. And recruiting and retaining high-caliber people is only possible with resources like the endowed fellowships, professorships, and chairs, which allow us to reward outstanding students, staff, and faculty, and provide them with venture funding for research and the exploration of new ideas. And the CSE department is an exemplar of this kind of activity. The Wissner Slivka Endowed Chair will recognize in perpetuity the commitment of the Wissner Slivka Foundation to computer science, education, and research at the UW. And at the same time tonight, we have the opportunity to acknowledge the outstanding scholarship of Professor Hank Levy by installing him as the inaugural holder of the Wissner Slivka Endowed Chair. So please join me in applauding Professor Hank Levy for his outstanding contributions to computer architecture and computer systems design, his role as an educator and mentor for future engineering leaders, and for everything he does for this department, for the college, and for the university. Hank? We cannot enumerate all the contributions Hank has made because it would take all night. The food would get cold and begin to rot, and we just really, we have to move on. But Hank has done tremendous things for this place, and he's the ideal exemplar first holder of this chair. To commemorate this special occasion, I'd like to invite President Emmert, Ed, Ben, and Lisa to join me in making 2 presentations to Professor Levy. So if you could all join me up here. Let me first ask Ben and Lisa to unveil the framed certificate and read the text.
The University of Washington recognizes Henry M. Levy in 2004 the Wissner Slivka Chair in Computer Science and Engineering.
And I'll ask President Emmert to explain the significance of the medallion and to present that to Hank.
Well, first, let me get my glasses so I can read the inscription on the back. It says, Henry M. Levy, Wissner Slivka Chair in Computer Science and Engineering, 2004. And this is, of course, the university medal, which will be worn at all ceremonial events. And what this now requires is the wearer to always show up at every commencement exercise in full regalia. Yeah. And, right? And it is a great pleasure, Hank, to give you this wonderful university medal.
Thank you very much.
Congratulations. Thank you.
We now have some remarks by Hank Levy.
Giving a talk without PowerPoint these days is kind of like jumping out of an airplane without a parachute, so I have notes. I'd like to thank President Emmert and Dean Denton for being here tonight to celebrate with us. I'd especially like to thank Ben and Lisa for their generous gift to the department and to the university. And I'd also like to recognize Ben and thank him for his work with us, coming to meetings, talking to our students, and really participating in the department and also his interest in the design of the building. And I'd like to thank all of my friends, colleagues, and students who are here tonight, and my family, Renee and Adam and Lior, who've had to put up with my addiction to computers over the years. So in Ed's original schedule for tonight, he listed this slot, and I quote, as 20 minutes of semi-technical mumbo-jumbo by Hank. So with that in mind, those were my precise marching orders for what follows. It could have been worse. He started with an hour. So it's hard to believe, but I've been at UW for 21 years now. I guess that makes me an adult. It seems fitting to use this occasion to reminisce a little bit about my time at UW, and in particular, how we became one of the very top systems schools in the country, something I've had the joy to see and to participate in. A lot of this history is lost or forgotten, and in fact, I've forgotten most of it myself. Forgetting is, of course, part of the job of being an absent-minded professor. This doesn't escape our students, by the way. A few years ago, Anna Carlin, who's here, and I were meeting with one of our senior grad students, Jeff Volker, and one of our younger grad students, Greta Bartels. At the start of the meeting, Greta charged in, enthusiastically telling us what she had done that week, starting right where she had left off the week before. Jeff immediately stopped her to educate Greta from his experience. "Look," he said, "you have to give them the whole story each time. Just treat them like your grandparents. They don't have any memory from week to week." In any case, to go back in time, in 1980, I was working at Digital Equipment Corporation, which was then the world's second largest computer company and one of the best computer engineering companies that's ever existed. DEC was eventually acquired by Compaq, which then merged with HP. The fact that DEC no longer exists is an interesting commentary on the rapidity and magnitude of the changes in our field. DEC had offered me a kind of sabbatical to spend a year at a university, and I was considering two places, Berkeley and Stanford. However, in the midst of this, Ed got wind of my plan in that way that Ed sort of gets wind of almost everything. And the next thing I knew, I was flying to Seattle to check out the University of Washington. I have to admit that both Seattle and the computer science department in 1980 seemed a little bit sleepy. Nevertheless, I chose UW over the others, in part because there was something more comfortable here, and I really liked the people. Manny Blum, then chairman of Berkeley Computer Science, told me honestly that if I had a technical agenda, I would have more impact and success at UW because Berkeley had a long history of consuming visitors by giving them the honor of teaching 3 or 4 courses during a one-year stay. 1980 was an exciting time to be here. While the department had really no history of large-scale systems research, it had just received the very first of a new class of National Science Foundation awards, a 5-year, $5 million grant for a project led by Jerry Noe, who's with us tonight, to explore integrated distributed computing. I should say that $5 million in 1980 was a lot of money, as it is today. Think of this idea as an operating system to support distributed programs on local area networks. Just to set some context, in 1980, local area networks existed only in research labs. Ethernet had just been standardized, and the first products were still in development. The entire computer science department, all of us, were running on a single time-shared VAC 780 computer, the blue box hidden in the corner over there. By comparison, a 3 gigahertz PC that you buy today for $500 is 3,000 times more powerful than that VAX, which cost $500,000. So if you figure that out, that's an improvement in cost and performance of a factor of 3 million in 20 years, which is another amazing comment on the rate of innovation in our field. While nobody had distributed systems in 1980, it was clear that someday in the future, these systems would be commonplace, and that programming them using existing paradigms would be extremely difficult. The goal of the Eden system, as the project here was called, was to solve a problem that people didn't yet know they had, how to build distributed programs. The key insight was to use objects, a model and technology that was very controversial in both the operating system world and the languages world at the time. Basically, the idea was that every resource in the network, a file, a printer, a mail message, a disk, whatever, would be represented as an object. An object is just some data describing the thing, bound together with some procedures that operate on that data. Programs in Eden could access any object in the network just by calling a procedure without worrying about where the object was actually located in the network. The Eden system would take care of finding out where the object was, managing the communication, all invisibly to the programmer. You might recognize this as the equivalent of what we now call remote procedure call, which was also in its infancy, since the major paper on that topic by Nelson and Birrell did not appear until 1984. This distributed object model, or RPC model, that I've described forms the dominant paradigm for Internet programming today, whether it's Java J2EE or Corba or .NET or whatever. People take it for granted. So it's hard to convey just how controversial the idea was at the time of distributed objects and this kind of remote communication. People thought that distributed objects would never work, would be too slow, and were basically dumb. In fact, the world had not yet accepted objects, even in the non-distributed world. C++ would not be invented for several years, and Java wouldn't appear for over a decade. Ed and I wrote the first paper on Eden, along with our co-authors, including Guy Alms, then an assistant professor here. Guy gave that paper at the 1981 Operating System Symposium. And I still remember clearly the end of Guy's talk, when John Osterhout, a professor at Berkeley, not a big fan of objects, jumped up and yelled aggressively, "Is this really your research, or is this your proposal?" In fact, it was just a proposal. We'd been very creative in embellishing the paper with architectural ideas, most of which had not yet been implemented. I went back to DEC for 2 years and then returned here as a research faculty member in 1983, ostensibly for a 2-year stay. After 2 years, I decided to remain here. After 4 years, DEC decided to stop paying me, which is maybe another comment about why they no longer exist. The Eden Project was still alive when I arrived, but was limping along, and in fact, some ways the project was confirming exactly some of the fears that people had raised about distributed objects. The project had come face to face with the difficulty of implementing even a prototype operating system in a university. There was also a hardware problem. Remember that you couldn't buy not even a PC, but a single-user workstation in 1980. So the team was trying to build their own machine based on the Intel 432 processor, which never made it to production. And they were even building their own display monitor, which, believe it or not, was housed in a custom-made oak enclosure. Turns out if you want to make 10,000 of something, it's cheaper to do plastic, but if you want to do one, it's cheaper to go to a cabinet shop and have somebody do it by hand. As for the software, there's a prototype version of Eden which was aptly named Newark, the idea being it's not Eden, but it's home. And the performance of the system was pretty awful. Just after I arrived, I heard a talk by 2 grad students, Eric Yule and Norm Hutchinson, explaining how the prototype worked and how it was used. One of the problems at the time was that communication between objects was extremely slow. On Eden, it turns out, communication over the network was as fast as local communication. Or to put it another way that's less generous, communication between objects on the same machine was almost as slow as over the network. Norm and Eric told me that Eden programmers would actually use 2 different programming languages to write programs, one for distributed objects and another for local objects, so they could avoid the cost of Eden when it wasn't necessary. I pulled Norm and Eric aside afterwards and mentioned that this was really a crazy way to do things. And our discussions led to Emerald, a new system that integrated an ambitious new object-based programming language, an incredibly advanced compiler, and a runtime system that together supported very lightweight distributed objects. This was the first system to support the idea of mobile objects, that is, code and data that move dynamically around the network. If only we had patented this idea. It was one of the first programming languages to fully integrate distribution. In fact, even our compiler was built on top of distributed objects. In Emerald, there were a number of different implementations for objects, but they were completely hidden from the programmer. The programmer would just say what he or she wanted, and the compiler would figure out the best way to do it, the highest performance implementation. And this made for a distributed system with excellent performance, really the first such distributed object system. Even by current standards, this was very advanced, and that was 20 years ago. We did a lot of nasty hacks to make this work, and that was a lot of fun. And I think this is still maybe the most ambitious project I've worked on. And our paper on object mobility in Emerald won a Best Paper Award at the OS Symposium in 1987. In retrospect, we and I were incredibly lucky. First of all, I had never run a research project before. In fact, I had never really done research. As some of you know, although I had wangled myself into a faculty position here, I had neglected to do a PhD. So I told you I'm very forgetful. Second of all, I had no students, so I borrowed Norm and Eric from Eden. Although to the credit of the department and to the project, nobody complained about it. Turns out that by accident, I had borrowed one of the smartest students we've ever had, Norm Hutchinson. Third, I had no funding, but I quickly learned about funding. We submitted our first research proposal on Emerald to NSF, and it was rejected. The reviews basically said, great idea, but it sounds impossible. So a year later, we tried again. We sent our second proposal. Rejected. Interesting project, too hard to do. The third year, we sent in a proposal just for kicks. There was no reason really to send one in anymore. We were pretty much done with the project. This time, the reviews complained, it sounds like you're proposing something you've already done, which was true, but they approved the grant anyway. So I learned the basic lesson of grant writing, never propose research you haven't already done. And this philosophy has kept me with grant support pretty much continuously now for 20 years. With Emerald and Eden, we had tried to solve a future problem, how to write distributed programs, before distribution was widespread. In the mid-'80s, we received an incredible gift from DEC's Palo Alto Research Group, a set of single-user multiprocessor workstations, each with 5 VAX processors inside. This was something you couldn't buy for any amount of money in 1980s. Even today, I don't know anyone who has a PC with 5 processors in it on their desk. This led us to the next question. If the future will be full of parallel machines, what will they look like and how will we program them? So we used a local area network to cobble together really a bunch of these 5 processor workstations, creating essentially a virtual multiprocessor with 20 or 30 CPUs. Based on our Emerald experience, we built a follow-on system called Amber that allowed programmers to write parallel programs without worrying about the difference between processors not on the network and processors in the same machine. In retrospect, this was one of the very first prototypes of what are now called NUMAs, non-uniform memory access machines, which are sold by companies like Sun and SGI and others. Jeff Chase, a super grad student, built this system. That work would have easily been enough for a PhD thesis, but Jeff somehow wasn't satisfied, so he put it aside and wanted to do something even more ambitious. At the time, I was thinking about 64-bit computers, which seemed just to be over the horizon. I thought that with large 64-bit address spaces, we could finally solve a number of significant system problems that had been plaguing us for decades. So we began work on a system called Opal, which explored a radical new operating system structure for 64-bit computers. This approach became known as the single address space operating system. This was in 1989. It's interesting that today, Intel and AMD are just starting to ship 64-bit chips in volume. So Opal was about 15 years ahead of the commodity technology which its design anticipated. As an aside, Intel's 64-bit Itanium processor, the one that probably isn't going to make it, has special memory protection to support systems like Opal, which we proposed back then. I'd like to mention one final event that occurred in 1986. We got a very cocky new grad student from Berkeley. His name was Brian Bershad. Brian came to UW because he had pissed off so many of the professors at Berkeley that they wouldn't take him as a grad student there. But Brian had incredible drive and energy, and in fact, he arrived in June, the summer before school started, and we worked together that summer, and he finished his first paper before the end of his first quarter here. After that, Brian and I began working with Ed and with another great grad student, Tom Anderson, who arrived the following fall. It was really the output of this group of 4 that put UW systems on the map. We worked on high-speed communications and operating systems, on lightweight thread systems, on fast synchronization for multiprocessors, and on architecture. This work was highly influential, and in fact, we won Best Paper Awards for that work at the next 2 OS conferences, which made 3 in a row for us and cemented us as leaders in the community. We in our work were sometimes controversial as well. I'll give you 2 little examples. I still remember an email I received in 1981 from Dave Patterson, one of the leading researchers in computer architecture in the world and program chair for a major conference in the field that year. The email said, "I have good news and bad news. The good news, your paper has been accepted. The bad news is that the paper will be attacked, and I will be the primary attacker." He finished by saying, "Do not allow a student to give this paper." That was a great challenge and made for an exciting talk. I think I gave Dave a lot more grief than I received, and afterwards he asked me to chair the following conference. There was one more particular run-in with Dave that was really memorable. A few years later, Patterson ran a workshop around a big research effort he was conducting at Berkeley on networks of workstations. At the end of the workshop, Ed went up to the podium, put on a clown nose, and proceeded to give a 30-minute appraisal of the Berkeley research, wearing the clown nose the entire time to diffuse the tension. Dave came up to the podium afterwards, amidst the applause and cheers and laughs, and stood there speechless for a couple moments, not knowing what to say. Finally, he picked up the microphone and said, "That was the most serious talk I've ever seen a clown give." But in the end, what really changed our visibility was the fact that Brian and Tom were the most sought-after PhD students in the country in 2 consecutive years. It made me very proud that both of them received faculty offers from MIT. It made me even prouder that both of them had the confidence to turn down faculty offers from MIT. As most of you know, Brian and Tom took faculty positions at Carnegie Mellon and Berkeley, respectively, and both have now returned to faculty here and have contributed enormously to the department. There have been a number of great systems research projects since that time, but this was the decade that really created our reputation, and I thought I'd take the opportunity to talk about it tonight. Since that time, we've been blessed with another generation of terrific students who are now technical leaders on their own, both in academia and at companies like Google and Amazon and Microsoft. What's amazing is that the technology continues to change at an even more rapid pace. And with the help of our great students and faculty, and with supporters like Ben and Lisa, I'm sure we'll continue to lay the foundations for the future of computing in the decades to come. Thank you all for coming tonight very much.
I want to once again congratulate Hank. I want to once again thank Ben and Lisa and all of you for being here this evening. And I hope you'll stay and join us at the reception and congratulate Hank yourself and thank Ben and Lisa. And by the way, Ben's parents are here tonight and members of his family, members of Hank's family. And again, thank all of you for joining us.